For this video, I'll be showing you how to use simple linear functions that you know from high school to solve a data science problem. Hi, my name is Percival Pagati. I'm a data scientist, and for this video, I'll be solving a real life problem just using high school maths. In this case, we are predicting mobile data usage, right? So the idea of this channel is we are using high school math to solve real life problems. So I'm going to giving you real life examples, and then I'll be taking high school math and show you how you could use high school math to solve those problems, right? So for this video, we're going to be using linear functions, simple linear functions to solve this problem. And here's the problem. The problem is, suppose you have a monthly data allowance of 60 gigabytes. So your mom or your dad, your parents are giving you a monthly allowance of mobile data of 60 gigabytes. And you want to predict when you run out of data during the month. Okay. So to do this, I gave you a hint here. So I said use linear function to model your data usage based on the following real data set. And the nice thing is, in this video, I'm going to be also showing you the way to actually get this data. There is an actual data that you can use to solve this problem. And I use my actual mobile data to solve this problem. I use my actual mobile data to solve this problem, and I'm going to be showing you how you can actually get this data as well yourself from your mobile data, from your mobile phone, and also I'll be showing you how to solve this problem. This is a data science problem, and if you understand this basic problem, you can able to solve other complex problems. So pause the video and try to solve this problem yourself, and let me know how far you went. All right, so let's come back again. Suppose you have a monthly data allowance of 60 gigabytes and you want to predict when you will run out of data during the month. It's very important. Your parent, they give you 60 gigabytes and you want to know when exactly you're going to run out of this 60 gigabytes, so that you can actually negotiate with your parents, say, hey, maybe this 60 gigabytes is not enough for me for this month, right? Because so what you're going to do is you look at your previous month and say, this is how much I've been spending for my previous month. Therefore, I am assuming based on my previous month spendings, then I'll be able to predict that I'm going to finish this data in this month, right? So you get your previous month's data, then you can able to predict can able to predict when you're gonna able to finish the 60 gigabytes, right? So how are you gonna do that? So firstly, as I said, the hint is you need to use your linear function. So your linear function says y is equal to m x plus c. So quick revision. What you need to know here is what is y, what is m, what is x, what is c. Because all of these letters, they mean something into a real problem, right? So when you're talking about y is a dependent variable. So y is a variable that is dependent, and this variable is dependent to this independent variable. So y and x, these are both variables, right? And x is an independent variable, is a variable that is not affected by anything, right? Just like time is not affected by anything, right? Time exists independent of anything. Right now, we're going to be spending time together, and this time exists independent of this video, independent of us spending this time together. And then y is something that is dependent. So you have an independent variable and you have an independent variable. This is what this y and x mean, right? And then I'm going to show you more and more in this video. Don't worry if you don't get it now, right? And then M is what you call a gradient. I mean, gradient is a big word, but what is a gradient? A gradient is a rate of change. That's what a gradient is. A gradient is a rate of change. So now, what is rate of change? It's just talking about a speed, how fast something changes from point A to point B. So rate of change is how fast the dependent variable change from the first independent variable to the second independent variable. That's what gradient means. Gradient means how fast the independent variable, let's say the independent variable move from y1 to y2, how fast that movement goes in the independent variable from x1 to x2. That's basically what is a gradient. Think about it. It says how fast. It's very important, and I'm stressing this because you need to understand what these letters mean so that you can able to apply them in the vast different examples, right? If you understand them in this conceptual level, you can able to apply them in any example that can be given to you. So let me repeat this. So a gradient is how fast you're changing from point A to point B. That's basically what it is, rate of change. And then you have what you call C. A C is an intercept. So what is an intercept? Actually, an intercept is when an independent variable is 0. What is your C? It depends on your use case. So when an independent is 0, what is your C? Now you need to be able to identify what is an independent variable. You need to identify what is dependent variable. And then from there you can able to identify your C, your intercept. Your intercept is when x is equal to 0. Right? And what is your y? So basically, when your x is equal to 0, what is your dependent variable? That is your intercept. That depends on the context of your problem. Now let's come back into our problem. The problem here is, suppose you have a monthly data allowance of 60 gigabytes and you want to predict when you run out of data during the month. Okay. So what is your dependent variable here? Suppose you have a monthly data allowance of 60 gigabytes and you want to predict when you're going to run out of data during the month. What is your dependent variable? Your dependent variable is your data usage, right? Your data. That's your dependent variable. So in this case, your dependent variable, your y, donates your data usage. Because this is the value that is dependent on how much you're using your data, right? Your data usage. This is the variable that is dependent on how much you're using your data usage. And what is dependent on? It's dependent on time. So how long you're using your data, right? Because you are trying to predict when are you gonna run out of data during the month. So you're predicting when. So that means you are looking at an independent variable. In this case is time. So in this case, in the month, you can say month or days if you want to, or dates. That it's really up to you. You can say days or date, right? Because you're looking at a date in the month or days in the month. Same thing in this context, doesn't matter. If you say days or dates, that's still fine. So your data usage and your days, this x is an independent variable, y is a dependent variable. So data usage and days. Please, if it doesn't make sense, comment and let me know what are you thinking, what are your thoughts, and I'm happy to explain this so that you can actually grasp it and understand it. Okay, so now from here you can then understand what is your y-intercept, right? You can understand what is your y-intercept without even having a data, without even having data, the actual numbers, right? So in this case, when you have data usage is equal to a gradient times days plus c. Okay, so we're saying that c is an intercept, right, where days is 0. So what is your data usage? So on day 0, not on day 1 when you start using your data, when you haven't start using your data, how much data have you used? That's basically what this is. Day 0, right? Day is 0 in this case. When days is 0, day 0, how much data have you used? You haven't start using your data yet. You haven't even used your data. I mean, you haven't start your day to use your data. So how much data have you used? 0. So when day is 0, your data usage is 0. So when you haven't started using your data, we haven't started a time to use your data, then your data have not been used. So when at day 0, then your data usage is 0. Make sense? When day is 0, therefore your data usage is 0. So your data usage is 0. So your C is equal to 0. C is an intercept. When you're having a day 0, therefore your data usage is 0. So therefore your C is 0. So now what you're left with data usage is equal to a gradient times days. That is your equation that you're going to use, which is essentially y is equal to mx plus c. In this case is mx plus 0, which is equal to mx, right? Because c is 0. Then you have mx. So you have mx. Now we need to figure out what is m, and m is a gradient. And to able to find a gradient, you need to able to find a rate. You say the gradient is a rate of change, right? So what is a rate of change in this context? For able to find the rate of change, how often the data change, you need to able to have a data to able to identify the rate of change. Now you need to go back now, say, cool, this is the data that you were given. This is how you can see your actual mobile data usage for every month in your phone, so that you can able to see where you're spending your most of your data, which apps are consuming most of your data, and how often, so you can get the data, you can do this calculation yourself for your own data. So you can go to settings, and then you can go to Facebook, WhatsApp, YouTube, LinkedIn, Instagram, Photos, Spotify, TikTok, and Chrome. So these are my most data usage for this month. And I mean, you can go more, check all the data and everything for a week, for a month, all of those nice things, right? So this is where you can actually see your data usage, and then you can actually record this data on yourself, put it in Excel, write it down, and do the calculation yourself. And you can able to figure out what is your average data usage, and when you can able to, so you can able to negotiate this with, right? Again, we said a gradient is equal to m is equal to rate of change, which is a gradient, right? Rate of change, how often, how fast you are moving from point A to point B, right? So meaning how fast we are consuming data from day 1 to day 2, from day 2 to day 3. How fast are we consuming your data from day 4 to day 5? So on average, how fast you are using your data. Basically, in this context, gradient is your average data usage. That is your gradient, your average data usage, how fast you are using this data daily, right? What is your average data usage? What is your daily average data usage? That's your gradient, how fast you're using this data on a daily basis. Then if you know your gradient, that is your gradient. You see, this is how you understand. So I understand most of the students, they complain about these letters and all of that. And I hope this video give you clarity about these letters. What does M mean? What does X mean? What does Y mean? What does C mean? So in this case, M is a rate of change. Now we dumb it down to our problem. Rate of change is how fast you're moving from A to point B. Now, so we're looking at this, how fast we're consuming data from day 1 to day 2, from day 2 to day 3, from day 3 to day 4, from day 4 to day 5. How fast are we doing that? So on average, how fast are we moving? That's basically what is happening here. So what you need to do is you need then to calculate the average of this here. You need to be able to calculate the average of this. So how do you calculate an average? So an average is X is equal to the sum of Y varies, which is in this case data usage, from 1 to N, which is 29. So from day 1 to day 29 over number of days, which is 29 as well. So you have 29 days. So essentially I can just say power n, which is 29 days. Or maybe I can actually write it down like this so that you can know the equation. This is the formula of a gradient. And then you can say this is the sum from day 1 to day 29 over 29. I should have not write X because we're looking at Y, so it's going to be Y bar. Okay, so we're mixing statistics. If you're looking at high school math, you're mixing statistics and linear function. That's what's happening here. Statistics and linear function. So from here, then you can say, okay, great. So you have, this is the formula for an average. An average in this case is equal to what? A gradient. Is equal to a gradient. And a gradient is an average of data usage. That's what we are calculating here. So how do you calculate this? Therefore, you have a gradient is equal to, there's no bar there, just a gradient. So a gradient is equal to the sum of y. So meaning you add this is the sum. Say 2.5, take your calculator, say 2.5.2 plus 2.4. These are gigabytes. So if this person has spent 2.5 gigabytes plus 2.4 gigabytes plus 1.19 gigabytes. So you add all of this until you go down there to 27, 28, 29. So you have 3.56 plus 2.18. You add of that and then you divide by 29 because it's 29 number of days. So if you do that in your calculator, so please do this in your calculator. I'll be doing that as well. All right, I'm getting 62.4136 divided by 29. So say 62 divided by 29. So your gradient is 2.1522. Let's put it that way. So that is your gradient. So what does this mean? It means that you're spending 2 gigabytes on daily basis. So you can now go to tell your mom and say, Mom, I'm spending 2 gigabytes every day. That's my average spend of data. I'm spending 2 gigabytes every day. Now we're going to go and tell your mom, then say, based on my previous month or based on my usage of data, of course, you don't have to use 1 month. You have to use multiple months. Let's say you use like the last 3 months. Use all this data to get your average of the last 3 months. Right? I'm just taking 1 month as an example, but you can take the last 3 months or the last year and say, Mom, for the last year, this is my average spend of data per day. and you're giving me a 60 gigabyte. Now, let me show you using maths that in the next when I am gonna run out of this data, because this is what the question is asking here. When are you gonna run out of this data of this is the gigabyte? So you have your equation again. You have your y is equal to mx plus c. Remember, your y is what you call data usage is equal to your gradient times days. So you are trying to figure out which day in the month you're gonna run out of your data. So what is your maximum data? Is 60 gigabytes. So you have 60 gigabytes is equal to your gradient, which is 2.1522 times x in this case, which is number of days. That's what you're trying to figure out, when you're gonna run out of 60 gigabytes. So then you're solving for days, so you can just divide by 2.1522 on both sides, right? So therefore, number of days is equal to, so you can take your calculator and say 60 divided by 2.1522. So you're spending 2 gigabytes daily. So on the day 27.87, 0.89, because of course we're talking about days here. So you can say, okay, I'm gonna run out of data on day 27. Day 27 or day 28, depending if you want to run down or run up, depending on use case. But I mean, we're submitting this to your mom, so you can say, Mom, I'm actually gonna run out of this 60 gigabyte on day 27, and can tell them, Mom, on average, every day I'm spending 2 gigabytes. And if I continue spending 2 gigabytes for the next month, every day, therefore I'm gonna be running out of this data on day 27. So the next 4 days I won't have data. Now you can now sit down and say, okay, cool. Do I then need to negotiate with my mom to put more data, or I can actually spend less of my data? Can I spend less of my data? Then you can use this equation to figure out to spend all of your data in daily days, how much on average you should spend. That's probably your next assignment. Just using linear functions, how much on average you should spend every day to able to use your necessity, to use your entire 60 gigabytes. And that's what you call budgeting. Now you're budgeting your resources. You have 60 gigabytes daily. How much should you use to able to? I think it's an easy math equation. If you figure that out, please comment below and tell me how much you should spend every day on average, so that you can use your 60 gigabytes in daily days. Boom. All right, so this is exciting. This is really great, and I appreciate for everyone who's participated and who understand the mission of this channel. Thank you so much for liking this video. Thank you so much for subscribing. Thank you so much for sharing this information with your fellow students. I want us to spread and grow this community and grow the love of mathematics, and also try to bring these real life examples so that you can see the reason why high school mathematics is important and what you can do with the high school mathematics. Boom. Squared minus 12x. Right? So what do we do? Find the first derivative. So what is the derivative of this?
Okay. It is 6x squared.
X squared. Good. What is the derivative of this?
Plus 6x.
6x. Good. What is the derivative of this?
Minus.
Minus 12, right? Minus 12. And then what do? You equate this to 0. So for x. So So you have 6x squared plus 6x minus 12 is equal to 0.
Yeah.
Then solve for x.
And then I solve for x, and then I get x1 and x2. And then I still remember this. Okay.